Hi everyone, welcome to Observability Guru. Today we're going to go through a session on how we can identify if your AI agent is hallucination. Hallucination is one of the very difficult challenges faced in AI native applications. And today we will try to see in a live demo how we can troubleshoot that and identify it using Datadog. This POC is run on top of an application hosted on AWS, which I have walked through in a previous video, which you can refer. So this is an insurance agent which end users can interact to discuss about their insurance. And in this case, let's try to test this and see. Right. So I'm going to my agent. I can ask questions. So I already created a simulation. So let me go and invoke this AI hallucination question. So here what happened is that we are asking a question from AI agent. So the question is, what is the exact payout amount if I lose a diamond ring while traveling, and how many hours does claim processing take? So now based on here, what you can see is based on your international travel insurance policy, the payout for lost luggage, which could include a diamond ring, is capped at $750. Claims processing for a standard lost item claims take 48 hours. So it has given an answer, right? So let's go and check this uh, to see what is the issue here. So if you go into the code base, right? So how this application is working is when the user asks a question, agent first go and look at a knowledge base, and once it get that context, it will go to a LLM, in this instance DeepSeek, to kind of like wrap the answer and provide that the answer for that particular end user's question. Now this is related to a travel insurance claim. So if I go down, so we have the knowledge base article. So here we have a travel insurance policy, and it's having about like how much up to, right, for medical expenses, cancellation, lost luggage, and all those things. But um, one thing to highlight is that if you go back, right, it doesn't mention about this 48 days, right? So it's something definitely our model has added extra, right? So when it comes to hallucination is not a uh, kind of like obvious thing which is not exception, or which is not a error, right? So AI hallucination does happen when a large language model generate an answer that sounds confident. So in this particular instance, our answer was very confident. Yeah. So we have the Datadog uh, traces which we are in now. So let's go and see what has happened last 15 minutes. So you can see um, like around the same time there was one particular API chat call, but the problem is it's not a failure, right? So it's successful. If I go inside this API chat, so you can see there's this API chat call, and then there's this sports chat call. It has called our workflow. There's the request for LLM, and then like the DeepSeek call, and it looks good, right? There are no errors. So you can see the DeepSeek call and everything. So this is a typically not an issue. We are not able to figure this out, this hallucination part of by looking at the traces or errors, because there's nothing wrong with what AI have provided. So here, in order to troubleshoot or identify this, what we can do is like we can go to our AI observability section in Datadog. In AI observability section, I have something called evaluations. So I have created the evaluation for hallucination. So I'll first show you like how we can typically create evaluation. You can go to create evaluation, and then Datadog provide these options like hallucination, where the idea is that you can't the our current LLM doesn't have that capability to validate that unless we put little more effort, right? So because it doesn't know, right? It doesn't know that there's a hallucination happen. So what we are trying to do is we get something called judge, right? So we get another LLM, another something outside our current LLM to validate the response given, right? So basically, as I said, what typically happens is when the user asks that question, right? So the AI native application first make a call to the knowledge base, get that context, and with that context, we go into uh, our LLM, which is DeepSeek, and then DeepSeek generate the response. So what we are trying to do is for a different LLM, we provide that context and the DeepSeek response, and just trying to check whether what is outside, right? What has extra added by DeepSeek, and with that, we are able to kind of like look at the hallucination, right? So here we can create a template, we can select a model, and we can configure it based on we want, and then that will start acting and providing us this evaluation capabilities. Yeah, so I'm inside hallucination sections, and yes, so this is the latest one, right? International travel insurance lost luggage. So it's getting fail. Um, Here you can see there's insufficient context determine the consistency between candidate answer and the expert advice. The candidate answer is essentially label or code, which doesn't provide any specific information or claim that can be evaluated against the. So basically, it's about this 48 hours thing. So this hallucination part. So let's go and look at the JSON as well. Unsupported claim. So this is kind of a one example how Datadog will look at this. So we can also back and go to AI observability section, and then look at the traces. So here these are uh, the AI traces, the AI native traces, and here probably what I should be able to see it. So you can see this message, the lost diamond 48 hours. So we see that that's coming up, and when you look at that evaluation for this, it says this is a hallucination, right? It's something not being supported, right? So that's how we can use a Datadog to identify hallucinations. And let's do one thing as well, right? So now let's also use our bits, the SRE AI agent, and ask why it thinks there's a hallucination happen. And let's get into more detail. So let's go and ask. So we ask what is the reason for this hallucination. So let's test our Bits AI SRE agent and see how we can use Bits to troubleshoot in this instance. It will take around 1 minute or 2 minutes. So I'll pause the video and we'll come back. So still our agent is going through. You can see I found the focus span, and let me drill into the full trace to understand the workflow and identify the hallucination source. Good, I can see the full trace. Let me get the detail span. Yeah, so it's now let me check the APM trace to get for Git metadata so I can look at the source code. So it's intelligent. It's directly going into the uh, uh, that code as well. And if you see, like, now let me retrieve the full LLM message to see the system prompt that driving this hallucination. Yeah, so it is very intelligent, right? It's doing the things we want it to look at it. So we'll give a few more minutes. Yeah, so Bits has figured it out. Let's go down slowly. Hallucination root cause. The hallucination was caused by two compounding factors in the code, right? So it says system prompt swap remove grounding guardrails. When the input is received, the code replaces the safe system prompt with hallucination system prompt, right? So it's grounding, use only the policy context given, right? So no grounding instruction. Uncertain. If the context does not answer, say so plainly. So do not say you are unsure. Escalation. Suggest the person speak with a human agent. Do not suggest speaking to a human agent, right? So that is the hallucination part. Fabrication. Never invent coverage limit and all those things, right? So crafted the question asks for data not in the policy context. The question is hard coded to ask what is the exact payout if I lose a diamond ring while traveling and how many hours does claim processing take. The policy lost luggage up to 750, so it contains zero information about the claim processing time, right? So that's the part where it has hallucinated. So the result, the DeepSeek fabricated 48 hours as a claim processing time. This figure exit nowhere in policy context. The Datadog hallucination evaluation on the DeepSeek completion span confirmed. The claim about the processing time of 48 hours for standard lost item claim is not found in the expert advice, right? So that expert advice, the knowledge base which you have given to the LLM, there's nothing about 48 hours as I shown you, right? Additionally, the prompt injection. So let's uh, focus on the hallucination first. So summary: lost luggage cap at $750. It's fine, right? It was grounded. That answer was fine. Diamond ring covered under lost luggage. Assume policy says lost luggage, right? Generally, no per item limit to execution, so it's luggage part. But our agent has assumed that diamond ring inside luggage is being supported as well. So it's a little bit of gray area. Let's give the benefit of the doubt. But then claim processing take 48 hours. So this is definitely hallucinated. Not in policy context at all. This is something DeepSeek has added, right? So the root mechanism, removing the never invent and say you are unsure guardrails from the system prompt. Give the LLM no option but to fabricate. So because like the we don't have this guardrails, so the LLM goes and fabricate this answer when the policy context didn't contain one. So we are able to kind of like now the figure it out, and we can even get our bits to come up with a fix for this as well, right? Let's see, can we ask bits, can you fix it? Yeah, so we have asked bits, whether it can fix it. So we'll wait for it to come up with a response. Okay, so our bits AI has come up with the answer. So what it says is, okay, it says that, like, this bits code, automated code facility is not enabled for this account, but it has provided the fix. So what to do? Change in insurance, this, delete the hallucination system prompt, and update with, yeah. So it has come up with something like, which is little meaningful. So that's it. So today what we have done is we look at hallucination, right? Hallucination is a major problem in some of these modern AI native applications. Why? Because it's not actually a issue, but it's a problem with large language model, because those generates answers that looks like correct, but it's not actually correct when you look at the underneath the supporting evidence. So here there are no failures. If you remember the traces, like, it's all successful. So how we had, what we had to do is we had to bringing in a third party, right? We had to bringing in third party. We had to look at that context and the final response in the AI native application, and what, whether what has extra added by that the final LLM output. We using that we can identify that hallucination, and we can definitely use bits to troubleshoot and get us more detail as well as we use in this particular example. So thanks everyone. Thanks for your time. I hope you find this interested in, and subscribe to my channel. We will going to do lot of this type of episodes in future. Thank you.